STTP in 2018. Sir has published various international conference and journal papers. 4 papers are published in SCI journal, 6 published in Scopus Index journals, and 2 in press, 21 international conferences, 5 national conferences, 4 book chapters, 2 research sponsored projects, 2 conference organized, 4 FDP organized, 2 patents design granted, and 2 patents published. He is guiding currently 4 students, PhD under him. So it's my privilege to welcome you, sir, on this platform, and we are looking for your kind words towards the topic artificial neural networks and its applications. Thank you, sir.
Thank you so much, sir, for my introduction and for inviting me in this program, a 6 days STTP, that is on machine learning and its applications on big data. I'm thankful to the management, organizer, and the complete committee members who have given this opportunity to me to share my knowledge with you all. Am I clearly audible?
Yes, sir. You are clearly audible.
So let me share my screen first.
Sure, sir. I'll stop sharing my screen and then you can share.
Hmm. So my screen is visible. Hello.
Yes, sir. Your screen is clearly visible.
Okay. So if there
Thank you,
is
sir.
any issue during the session, then please let me know because
Sure, sir.
it might be
Definitely.
difficult that sometimes if connectivity issue is there.
Yeah, yeah.
So
Yeah,
please
sir. We
let
understand, sir.
keep me updated regarding the
Sure,
same.
sure.
So,
Over to you, sir. Thank you.
thank you. Before starting the session, actually, I would like to share the thought process of this talk, which is scheduled just after the inaugural. Sir, whosoever is there, please mute your mic. Now it's fine. So I would like to share the thought process of keeping this session just after the inaugural because as we all know that everybody is nowadays we are focusing on a few buzzwords: machine learning, AI, deep learning, data science, big data. So these are the buzzwords nowadays, and we engineers are using these technologies in different areas, or we can say that we are using these tools in different areas. But we need to understand the fundamentals of these buzzwords. So that's why this artificial neural network and its application, this is kept as a first session just after the inaugural, that if we will study machine learning techniques, but we need to understand the fundamental or basics of machine learning. So this can be understood by the slides. The complete flow of the presentation will be: the first I will discuss about the basic introduction of the neuron, then how neurons will communicate with each other.
आवाज ही नहीं आ रही है.
Hello.
Your
Hello.
voice is audible. Hello.
Yes, sir. Somebody was
Yes,
saying.
sir, you are audible. No problem on my part.
Okay, sir. Thank you. And then I will discuss about the artificial neural network, then the components of artificial neural network. Then first activation function, then what are the different topologies, then learning algorithms. Since my objective is to introduce about NN tool.
साइफलम गायब कर रहे हैं आप? तो इसका सुनिए, इसका एक ही फॉर्म ये वाला करना है, बस
Sir,
यही फिर 3 साल के लिए हो जाएगा।
sir, please, whosoever is there, please mute your mic.
Excuse me, guys. All the participants are requested to mute their mics. Please don't switch on your mic in between and
If
just
there is any question,
if you
then you
are
can
having
ask.
any question, yes, sure, you can ask. Thank you, sir.
So my main objective is to discuss this NN tool, how this NN tool is used on MATLAB. So we will move fast in the theory session. That's why we can focus on this NN tool, how it is utilized, and a few hands-on session on OneNote, that how this training is uh, implemented in neural network. So this theory part is just for the introduction purpose, that before studying artificial neural network, we need to understand the basics of artificial neural network, and before that, the neuron, which is the basic basis for this artificial neural network. Then, as I have already mentioned, that the buzzwords, so we can understand clearly that this can be understood with the help of Russian nesting dolls. These Russian nesting dolls initially uh, were used for the explanation about the unity of body, soul, mind, and heart and spirit. So actually, it is too much difficult to separate these things, and they need to explain these concepts. So these Russian nesting dolls were used, and those dolls can be also used for explaining this, that artificial intelligence, machine learning, neural network, and deep learning. So we can this artificial intelligence, machine learning, and basically these two terms, we can't separate these AI, ML, NN, and deep learning. These are the subsets, or we can say one is set and another one is subset. So neural network as the basic of AI and ML. That's why we are discussing a neural network in this first session. Then difference between this ML and deep learning. This is also, we need to understand this difference, that what is the difference between two, NN and deep learning. Generally these two words can be used as interchangeably, but the deep learning, the word deep is related to the number of layers. So those who are having a little bit information about neural network, then they might be aware about the layers. If you are not aware, you are listening first time, then we will discuss about the layers in the session few few times later. Then, so if there are more number of layers, then that will be deep learning. If number of layers are less, then that will be neural network. This is the basic difference. So a neural network that consists of more than three layers, if more than three layers means the problems will be that problem will be little bit more complicated. So that can be that algorithm to train that neural network, that will be deep learning algorithm, or the, as I'm saying, that training means actually this neural network is just like that we are having one box, we are giving input, and we are taking output. So suppose we are not having any information about this. This is this model. We are not having any mathematical information about this block. So then in that case, training will be done. Suppose I am giving input 1 and this is giving output as 2. Then we can conclude, we can say at this point that if I am giving input 1, giving 2, so it means there will be a mathematical operation, means it is doubling the signal, but we can't comment that it is right, or it is the perfect model for this box. So what we will do, we will train this model. We, for n number of inputs, suppose I'm giving 1 2 3 4 5 6 6 and up to n inputs, and each time if I am getting the output double of input, in that case we can say that this input box is having a mathematical equation which is processing in this way, that whatever input will be given to this model, it will just double its output. So this process is training. We are giving different inputs and analyzing outputs, and then we will say that this is the mathematical model for this neural network or a model, whatever we are using. So we are discussing here about neural network because there are different areas of applications of neural network. You just name the area, we will find the application. The telecommunication, electronics, anomaly detection, speech, signal processing, medical. In nowadays in COVID condition, that this that analyzing the X-ray with the help of image processing, then aerospace, industrial, software, automotive, time series prediction, which we will discuss in today's session also, that forecasting. Then military application, you just name the area, you will find the application. Then, as I have already mentioned in a initial session, that first we will discuss about the basic of neuron. So neuron is the basic cell. The function of neuron is to receive and transmit information. So this is the basic structure. This consists of three basic parts: soma, dendrite, and axons. Or and this neuron uses biochemical reactions to receive and transmit information. So the signal flow will be from dendrite to axon terminal. So signal will flow from dendrite to axon. These axons of one neuron will be connected with the dendrites of another neuron, and their communication, the communication between two neurons will take place, which I will discuss in upcoming slides. These are the different parts of neuron with their functions. A nucleus, which controls the entire neuron, and then axon. This transfers the signals to another cell. Then axon terminal. These form the junction with the dendrite, and dendrite receives the signal. Then another some other parts are also there, but the main parts of the discussion will be these axon terminal and dendrites. So dendrites are input terminal. Here one neuron receives input from another neuron, and axons are, these are the output terminals. So one neuron will give output to another neuron, and then axon of one neuron will be connected with dendrites of another neuron. And then how neurons will communicate with each other. So these neurons will communicate at the junction, means where axon and dendrites are connected, and that junction is known as synapses. The process is electrochemical. So the electrochemical process means this will help, this process will occur through neurotransmitters. These neurotransmitters are the when neurotransmitter will transmit from one place to another place, it means we are sending one message from one place to another place. Then there are many type of neurotransmitters, means we are having different type of neurotransmitters. What will happen, some of them will stimulate neurons, means they will activate neuron just like catalyst, and some of them will inhibit. The resultant or action of neuron will depend on these signals. Why we are studying about this excited this the stimulation neurons, or these inhibition process or excitation process, because this is the fundamental of ANN. where we will find that different type of input signals are coming to one neuron, and then how the output will depend on those input terminals. That's why we are discussing about that how neurons will communicate with each other. Generally, that a neuron will remain at resting potential, but when that neuron will receive different input signals, some or different neurotransmitters, some are stimulating and some are inhibiting, but when resultant of all inputs is greater than a threshold value, that threshold value is generally known as action potential, then that neuron will fire. So then that neuron will start communicating with another neuron. So this is the general process. There are excitation signals, there are inhibition signal, but at a time when resultant of these two, excitation and inhibition signal, is greater than this has this threshold value, or this is known as action potential, then this neuron will fire, or these excitation and inhibition signal will continue. This is the continuous process. We can't say that these excitation and inhibition processes for a particular time, but this is continuous process. Then when this action potential reaches the presynaptic terminal, then what will happen? It will release, or it causes neurotransmitter to be released from neuron into synaptic cleft. Now what happens? The dendrite of one neuron received signal, then it excites, or its potential is greater than action potential, then this action potential will reach about these axon terminals. Then this axon terminal is connected with dendrite of another neuron. So this region, this is known as synaptic cleft, means the contact point of two neurons. These synapses can be thought as a converting an electrical signal, this is action potential, into chemical signal, because this action potential is electrical signal. So this electrical signal will reach up to axon terminal, and then this will release a neurotransmitter in this synaptic cleft, and again when dendrite of this another neuron will receive, then this neurotransmitter will again convert into electrical form. So these synapses can be thought of as converting electrical signal into chemical and again into electrical form. So this process can be better understood by this process. These are the neurotransmitters. These will reach into this synaptic cleft region, this short region. These are the axon terminals of one neuron, and these are the dendrites. So when this neurotransmitter will reach in this synaptic cleft, the receptor of another neuron will receive these neurotransmitter, the neurotransmitter, and then the message will be transferred from this neuron to this neuron. In this duration, there are different possible situations. One, when a brain cell receives sensory information, it fires an electrical impulse that travels down to the axon terminal, where neurotransmitters are stored. Then what will happen? This will release these chemical or these neurotransmitters in synaptic cleft. After this, what will happen? The messenger may be degraded and knocked out of the picture by an enzyme before it reaches its largest receptor. Means one thing is possible, that once this neurotransmitter is released, there is one possibility that this neurotransmitter will not reach up to this receptor. One. Another possibility, the messenger may be transported back into the axon terminal through a reuptake mechanism. A reuptake mechanism is that neurotransmitter is again absorbed into that the sender neuron. Then another case may be that this neurotransmitter may bind to another neuron, but it may happen that the signal is not sufficient to reach or to activate another neuron. So in that case, that another neuron may receive that signal, but that will not fire. So these are the few possibilities. So we have studied about the structure of neuron and how neurons are communicating with each other. This process is taken from neuron, or we can say that this process of communication between different neurons is utilized in artificial neural network. So this artificial neural network is this is efficient computation system which the theme is borrowed from analogy of biological neural network, and these are also known as artificial neural network and parallel distributed system, connectionist system. So different names are given to these ANN. Then these are not new. Since 1943, I'm not discussing about detail. Whosoever want to take these content, I can share. So it was started initially in 1943, then 49. That Habs book, that Habs behavior organization of behavior. Then 1958. This was the McCulloch-Pitts neuron. We can consider that this is the basic change from which neural network has uh, gained its growth, because the McCulloch-Pitts neuron is the fundamental of this ANN model. After that, different upgradation was done. Then, and in 1960, Adeline Madeline, and from 64, 69, 71, then 76, 82, 85, 86, 88, then 92, 97, 98, 2007, and 12 onwards. Nowadays, as I already mentioned, that we are studying about the machine learning and deep learning. So these are the advanced applications of neural network. Then a neural network can be, a simple neural network can be understood as an input layer, hidden layer, and output layer. Input and output layers are fixed. Hidden layers can vary. Number of hidden layers may vary, and the major processing of this artificial neural network happens in this hidden layer. So this is the basic structure of AN, artificial neural, artificial neuron. Here we can consider that these are different inputs A0, A1, A2, and AN. Different weights are added. These weights are corresponding to the excitation or inhibition. If these input are as exciting or these are connected as excitation signal, or these are increasing, stimulating the neuron, then the value of these weights will be positive. Otherwise, this can be considered as negative. So then this is the weighted input, this as J. Then in neurons, we used to consider the threshold value, that is action potential. So for that action potential, this is the output will be function of this weighted input. We can clearly understood with this that each neuron has a threshold value. So some weighted input, this y1, y2, y3, yi, these are the inputs. Then these are the weights, w1j, 2j, 3j, 4j. Then this will be weighted input, means this this weighted input will be y1 w1j plus y2 w2j and yn w nj. So this is the net input. This net input will be given to this threshold value. If this net input is less than threshold value, then we will not get any output. If this less input is greater than threshold value, we will get output. So these inputs will be continuously provided to a neuron, but output will depend on this threshold value. So if the activation level exceeds the threshold value, the neuron fires. Or and input signals form a weighted sum. So some weighted sum means input multiplied by weight, and this will be added. So this is the same explanation that x1, x2, x3, xn, xm, these are the inputs, weights are the w1, w2, wm. This yin is the weighted input, and then this yin is given to the activation function. Role of activation function is will be discussed in the upcoming slide. Then the output, this activation function will decide the threshold, that this, if the input is greater than threshold, then we will get output, otherwise we will not get any output. So output is function of net input. This y is function of net input, and net input is this, as I have already explained you. This can be written as summation of this also. So output will depend on activation function, one thing. Then this processing of ANN will depend on, one thing is activation function, which I have already explained. Second one is adjustment of weight or learning. Adjustment of weight means, suppose because once you have designed the that neuron, artificial neuron, you have fixed the activation function, and if you want to fire, then you have to change the input. Then also if inputs are fixed, then you can change the weight only. So output depend on this activation function, then the weights, and third thing is network topology. Then what is activation function? These activation functions are mathematical equations which determines the output of a neural network, or this is also known as transfer function. And these activation functions helps in normalizing output, means you will get output 1 or 0 or -1 and 1. As I have already mentioned, that if net input is less than threshold value, then output will be 0, and if it is greater than or equal to threshold value, then output may be 1. So this may be 0 or 1, or you can consider it as -1 or 1. It will depend on our requirement, that how we are selecting the output, -1 or 1. So this can be considered as a mathematical gate. This is the input, or the right word is weighted input or net input. This net input is given to activation function, and then you will get the output. So activation function is working like a mathematical gate. We can change this activation function, and then accordingly we can change the output for a same net input. Or if activation function is fixed, then we can change the weight, as it is mentioned in previous slide. So the basic process carried out by a neural network: take input and multiply neurons weight. So that is W1 X1. If there is any bias, then add this. Feed the result to the activation function. This is Fx, means that input, and then take the output. Generally, these activation functions are divided into two parts: linear and non-linear. As I have already mentioned, that I am covering this theory part very fast, because my main motive is to introduce the NN tool. These are the different types of activation functions which can be used. That identity, binary step, logistic, these are their equation, and these are the derivatives. So from identity to soft plus, which type of activation function you are selecting, that depends on your requirement or your problem. So selection of these activation function is important. There are different types are given, but you have to select activation function as per your problem. Then this point, why derivative or differentiation is used. because, or another, in another way you can say that why this activation function should be differentiable. This should be differentiable because it decides the direction and magnitude. So when updating the curve, to know that in which direction and how much to change or update the curve, when we will study, or whenever you will study about the gradient descent algorithm, in that case you need to decide that the curve will be in next epoch or in next iteration, how this curve will be updated. So at that time differentiation is more important. Due to this it is considered that every activation function should be differentiable. That's why you can say that in this comparison, the equation and its derivative is mentioned. Then a network topology means how this, up to this point we have studied about a neuron. Then network topology means different neurons are connected in a manner to form a neural network. So how those neurons are connected, that is a network topology. That means arrangement of network along with its node and connecting lines, means different the connection fashion of different neurons is network topology, because when different neurons will be connected, then they will form a neural network. So the architecture of artificial neural network defines the how several neurons are arranged or placed. So these are the neurons V1, V2, V3, or these are the nodes, you can say that, or vertices, and these connected or connection fashion, then this E1, E2, E3, E4, E5, this is the weight. So connection pattern of different neurons is known as network topology. Generally, in neural network architecture, three layers are there: input, hidden, and output layer. The input layer is responsible for receiving input signals or data, and that output layer is responsible for the production of output. Hidden layer is responsible for processing. This hidden layer, this is also known as intermediate layer or invisible layer, because in network we will generally see input and output layer. Two types topology are there. One is feed forward, another one is feedback. In feed forward network, that every node will be connected with previous layers, and no feedback loop is there in feed forward network. In feed, this is single layer feed forward. These are the input neurons, and these neurons will connected, these are connected with another output layer. So every neuron is connected with other neuron, or the neurons of other layer. We can say, we can clearly see that this neuron is connected with this and this. So every neuron or every unit is connected with other uh, other units, or the units present in other layer. Single layer feed this, I have already explained that weight connects every input to every output, but not other way. So that's why it is feed forward. Then multi-layered, this is hidden layer. In this case, you can also see that this neuron is connected with this, and the hidden layer unit is also connected with this. So this input layer neurons are connected with hidden layer neurons, or this will be connected to previous one or next one. So there is interconnection between previous layer and present layer. So output will be connected to hidden, and hidden will be connected to input if this is multi-layer feed forward. Single layer, this hidden layer is absent. this these multi-layer feed forward networks are generally known as LMN, means how many neurons are there in input, output, and hidden layer. Then feedback network. In this, feedback will be provided. The signal can flow in both directions. Since the flow of signal will be in both directions, so these are little bit complicated. These are dynamic also because the continuous input will be provided, or the continuous feedback will be provided. So the state of these network will be continuously changing, and this will change up to the equilibrium point. And this equilibrium point will change as if there is any change in input or the conditions of that neural network. So feedback neural network, this is also referred to as interactive or recurrent because it is continuously changing up to equilibrium point. And these are of two types, fully recurrent and Jordan. This is fully recurrent. You can clearly see that each unit is connected with remaining units in bidirectional way. And in Jordan network, this feedback is provided, or these input and output layers are connected. So this is the basic difference between this fully recurrent and Jordan network. Then learning. This is the main part because learning is mainly a complete neural network depends on this learning. So as I have already mentioned that this neural network is like a box or black box. You are giving some input and getting some output. So steps to train the network, that is known as learning algorithm. What are the different set of steps that we have to perform, and as for the change in steps, algorithm will change. So depending on that, that neural network learning algorithms are supervised, unsupervised, and reinforced. And in supervised, stochastic, error correction gradient, and back propagation. This back propagation algorithm is generally used, and then unsupervised, Hebbian, and competitive. Supervised learning, that a teacher is present. So this is neural network, input is given, this is actual output and desired output. This is actual output, and this is known as target. So if we are giving some input and we are having the information of desired output or target value, then an error signal will be generated depending upon actual output and desired output. So this error signal will be again given to neural network, and this will change its parameter to meet the actual output with the target. So in supervised learning, a teacher is present and this desired output is given, then error will be generated. In unsupervised learning, no teacher is present, means this output is target value is not given. So this neural network will learn by own. So desired output is not presented. The system learns by its own, and then on reinforced learning, a teacher is present but does not present the desired output. See the difference between reinforcement learning and supervised learning. In supervised learning, this the target is provided and error signal is generated depending upon actual output and target value. But in the reinforcement learning, this teacher is present, but it is not giving any target signal or any target value. Only a reward is given for correct answer and penalty for wrong answer. Means this error signal will be generated depending upon this that output, and that then if it is correct or if it is wrong. So these are the three learning algorithm. Then, as I have already discussed in the previous slides also, that different methodologies or different set of steps, they will uh, define. Hello, any issue? No, thank you. So a different set of mathematical rules will define the learning algorithm. So have proposed one learning algorithm, that is correlative weight adjustment. The mathematics, I am not going in detail about the mathematics, because each algorithm is having its own mathematics or a own set of rules. Whenever you will apply any type of algorithm, then you have to study in detail about that algorithm or mathematics of that algorithm.
దీన్ని
So
ఎక్సెసిబుల్ పార్ట్ రాసుకోమన్నారు రాసుకోలేదే
participants, please mute yourself. If there is any
అందుకే అడిగింది
question, then you can ask.
సిక్స్ పార్ట్ జెడ్ వాల్యూ కనుక్కో జెడ్ ఈజ్ ఈక్వల్ ఎక్స్ మైనస్ మీ బై సిగ్మా అంటే రెండు
Hello.
మాకు మీకు తెలుసు ఎక్స్ టెన్
All
జెడ్ ఈజ్ ఈక్వల్
participants
ఎక్స్
are
మైనస్
requested to please mute yourself.
ఎస్ ఏమండి
Hello.
ఈ
Okay.
రాసుకున్నారు కదా ఎక్స్ ఈజ్ ఈక్వల్ టు 40 అని
So flowchart, which is proposed by HAB, I have already mentioned that I am not going into detail about this mathematics. What one main point which I want to mention here, that they want to adjust weight. In previous slide, I have mentioned that there are parameters on which output of neural network depends. One is activation function and another one is weight. So once you have decided or fixed the neural network, means you have selected that activation function. Now to train the network, the only one thing is possible, that you can change the weight, because input you have fixed. So this weight will be updated according to our requirement, that our output is as per the requirement or not, or output is meeting the target value or not. So weight updates or the steps for updating the weights will be, or these are explained in different algorithms. So another one is gradient descent algorithm. In this is based on minimization of errors, and in this activation function of network is required to be differentiable, because in this case you have to differentiate this error signal with respect to weight. So then another one is competitive learning algorithm. In this method, those neurons will respond strongly who are, or we can say that the strategy winner takes all. This strategy is followed in competitive learning algorithm. Then stochastic learning, in this the all weights are adjusted in probabilistic manner. Now I will come to the point where I want to discuss few examples, or examples which are solved by hand, that how these weights are changed, or how network is, or neural network is trained. So from basic question, that generate the output of logic and function by McLeod Pitts neuron. So we are aware that for AND signal, or sorry, AND gate, one is input. There are two inputs, x1 and x2. Then this y is the activation function, and then output. So our objective is to generate output of logic AND. Output of logic AND can be generated by this process. For AND means multiply, so x1 x2 are the input, we will this is the actual truth table of AND gate, that 0 0 output is 0, 0 1 output is 0, 1 0 output is 0, 1 1 output is 1. So four different cases are there. Now we are not having any information of this W1 and W2. What will be the value of W1 and W2, and what will be this activation function? So for y in 1, y in 1 means when these two inputs are there, four cases are there, y in 1, y in 2, y in 3 and y in 4. So when x1 x2 are 0, so let us assume that W1 and W2 are 1 initially. So y in 1 will be 0 into 1 plus 0 into 1. So this is 0 and this output is 0, and for this input our target is 0. So in this case output and target both are matching. So at this stage we can say that the value W1 and W2 which we have selected as 1, this is okay. Then in next stage y in 2, for second case x1 is 0 or x2 is 1. So if x1 is 0, x2 is 1, so 0 into 1 plus 1 into 1. Now in the next stage also we are considering W1 W2 as 1, weight are considered as 1. So 0 into 1 plus 1 into 1, this will be equal to 1. This is 1, but output is output is 1, but our target is 0. So we will think that what we can do, we can change the activation function or not. Then come to third input. If 1 into 1, because x1 is 1, x2 is 0, so 1 into 1, so this will be 1, then 0 into 1, so this is 0, so 1 plus 0, this is 1, our target is 0. Then another one is 1 into 1 and 1 into 1. So this will give us 2. So for this weight W1 and W2 is equal to 1. Our values are 0, 1, 1. Net input values are 0, 1, 1 and 2. And our output or target is 0, 0, 0 and 1. So we can select any activation function that is giving us the value of 1 if net input is equal to or greater than 2, otherwise 0. So the mathematical equation for that activation function will be this: y out will be equal to 0 if y in is less than 2, or if y in is greater than 2 or equal to 2, then this will give us value of 1. So in this case W1 and W2, 1 is final. If we will adjust this activation function in such a way that this mathematical gate is working in such a manner that if input is less than 2, then output is 0, and if input is greater than equal to 2, then its output is 1, then this will give us the logic of AND gate. Then second, logic of OR gate also. In OR gate, x1 and x2, these are the 0 0 1 1 0 1 0 1, and output of OR gate is 0 1 1 1. Now in this problem we will discuss the two different cases. One, in the previous example what we did, we have adjusted the activation function. Now come to this case. In first case is we have considered in this x1 x2 as 3. We will discuss two different cases in which x1 x2 are 3, and second when x1 x2 are 1. So if x1 x2 are 3, then what will be the case? If x1 sorry w1 w2 are 3, then what will be the case? X1 for y in 1, 0 into 3 plus 0 into 3, this will give us value 0, output is 0 and our target is 0. Then for second input means this 0 and 1, so 0 into 3 plus 1 into 3, this will give us the value of 3, but our output the target is 1. So we will adjust the activation function in this case. Then y in 3, 1 into 3 plus 0 into 3, this output means this output is actually net input. In activation in a neuron model, we have studied that this is the net input and this is activation function, and then this will give us the output. This is the model which we have studied. So for this case, two input, this is x1 and this is x2, this is w1 and this is w2. So we are having the value of this x1 and x2, and output means target. So in this case, we can adjust only this w1, w2 or value of this activation function. So for this case, y in 3, 1 into 3 plus 0 into 3, output, this output or net input is 3, but our target is 1. Then for fourth input, this is 1 and 1. So 1 into 3 plus 1 into 3, this is output is 6 or net input is 6 and our target is 1. So for this case, this 0, 3, 3 and 6, these four are the net input and target is 0, 1, 1, 1. Now we have to fix the activation function, because for this net input, we want to output or our target value should be this, because we want to execute the logic of OR gate. So for this case, we can select an activation function in such a way that if input is less than 3, if it is greater than 3 then 1, greater than or equal to 3 then output should be 1, and if it is less than 3 then output should be 0. So this is for y. If yn is less than 3 then output is 0, if yn is greater than equal to 3 then output is 1. So this is the activation function for the case when w1 and w2 are selected as 3. But second case, if we are considering w1 and w2 as 1, so consider w1 and w2 as 1. So in this case, what will happen? This y in 1, this will be 0 into 1 plus 0 into 1, means this will be equal to 0. Target is 0. Target is 0 and net input is 0. Net output, we will check that net output will depend on activation function. Then y in 2, this will be 0 into 1 plus 1 into 1, this is 1. Y in 3, 1 into 1 plus 0 into 1, this is 1. Y in 4 is 1 into 1 plus 1 into 1, this is equal to 2. So the net input are 0, 1, 1 and 2. And our target is 0, 1, 1, 1. So our target is 0, 1, 1, 1. So now activation function will change because we have changed the value of w1 and w2. So activation function value in this case will be that output will be equal to 0 if yn is less than 1, and output will be equal to 1 if yn is greater than equal to 1. So activation function depends on value of w or value of weight. If we will change the w, the activation function will change for our target output. Then another example, in this case actually only input and output layers are there, hidden layer is not there. So the need of hidden layer can be understood in the XOR gate. Or for XOR gate, one more gate or logic of one more gate we need to study, that is AND NOT gate. This AND NOT gate is the out or logic of AND NOT is that it returns the true value 1 if only the first input is 1. If first input is 1, then output is 1, otherwise 0. So, and in this case, one main point which you need to keep, that if A and not B means A is the first input, B is the second input. So A and not B, 0 0 1 1 0 1 0 1. So it will result the value of 1 only if the first input is 1. So this case the output will be 1. And if x2 and not x1 will be there, if these are written in this way 0 0 1 1 0 1 0 1, so and x2 and not x1, so this will result only because in this case x2 is first input, so x2 is first input, so first input is 1 and other are 0, so x1 is 0, so it will return us the value of 1 for this net input. So this is the AND NOT logic. Now we have to adjust the weight for this AND NOT logic. The x1, x2, these are the two input and output. Now we have to adjust the weight. So first case, we have considered as weight as W1, W2, both value initially these are considered as 1. So x1 is 0, W1 is 1, so W1 x1 this is 0. W2 is 1, x2 is 0, so 0 into 0, sorry, 1, W2 is 1, x2 is 0, so this will be 0. Output is 0 and our target is 0. So it means at this stage we can say that W1, W2, the values considered for W1 and W2 are satisfying condition for this input y in 1. Now second case. Second case is x1 is 0. In this stage also we will consider W1, W2 as 1 because the 1 value of W1 and W2 are satisfying the condition for input 1. Then y in 2, x1 is 0, W1 is 1, W1 x1 is 0, W2 is 1, x2 is 1. So this is 1 into 1, 1. Now 1 plus 0, this will result the value of 1. So if this will result the value of 1, it means this 1 is not correct because our objective is this, the output should be 0 because in AND NOT logic, this in this case or for this input output should be 0. Then this output can be 0 only if this, either this is 0 or this is minus 1. So this 0 is not possible because weight of W2 you can't consider weight as 0. So you can consider W2 as minus 1. If you will consider W2 as minus 1, then this will be 1 into 0, 0, then minus 1 into 1, this will be minus 1. So output will be minus 1. So this minus 1 can be equal to 0. So now we will move up to third input. Now what we have updated, initial in this case W1 was 1, W2 was 1. Now in second stage W1 is 1 and W2 is minus 1. So for third input we will consider as W1, W2 at 1 and minus 1. So W1 is 1, X1 is 1, W1 X1 is 1, W2 we are considering is it is minus 1 and 0. So minus 1 and 0, this is 0, 1 into 1, 1, then output is 1. So this minus 1 is satisfying this condition. So or if we are considering 1 also, and in that case also it is satisfying condition because at this time x2 is 0. So output is 1 and target is 1. Now this in this fourth case 1 into 1 because W1 is 1. Here we are considering it as 1 and minus 1. So in the next stage also this condition is true. So in next stage also we will move with this weight 1 and minus 1. So y in 4, this is 1, 1. So 1 into 1, this is 1. W2 x2, this is W2 is minus 1. So minus 1 into 1. So this will be minus 1. So 1 and minus 1, this is 0. So this is 0, output is 0, target is 0. So it means the value of W1 and W2, which we have considered initially as 1 and minus 1, this is not correct. But during the training process, we have updated the value as 1 and minus 1. This is correct because the value 1 and minus 1 is giving the desired output, or output of this neuron the uh, is matching with target value. Now we have to decide the activation function for this case. In this case, this is 0, this is minus 1, this is 1, and this is 0. So this is the NAT input: 0, minus 1, 1, and 0, and our output should be 0, 0, 1, and 0. So the activation function can be decided in such a way that it will give us the value of output will be 1 if NAT input is 1 or greater than 1, and 0 if it is less than 1. Less than 1 means it is 0 or minus 1. And if this weight is minus 1, then NAT input will be minus 1. NAT input minus 1, then target value is 0. So this activation function for value of W1 and W2 as 1 and minus 1 can give us the output which is matching with the target value. Now, second case is realization of XOR, or the one more thing I can do, that I can leave up to this point, and I will move towards the MATLAB